Hey YouTube, what's going on here? Daniel Dallas. Alright, we're gonna go through quadratic functions revision. That's the second revision here, and we'll be struggling with the question how to find the vertex and axis of symmetry of parabola for a given, let's say, for a given form, for a given standard form mostly, because if it's given in the vertex form, no problem, guys. You just remember you can do it very easily. So if in vertex form, just simply make sure you remember that the vertex is hk coordinates, and this is the point. So for the equation y equals a times x minus h squared plus k, so that actually those guys h and k stays here, so that's h and that's k. If you're given this form, I think no problem. Here we consider the following revision questions and problems. So find the vertex, coordinates, and equation for axis of symmetry for each of the following quadratic functions, and then sketch their graphs. All right. So what we're gonna do, just you try, pause the video, try to do by your own. So that's the first two functions given here, and that's the rest part. Okay, so try to do by your own. I think the most guys that was watching, who was watching actually my videos explanation about the vertex form, about standard form, and how to plot it, actually they are able to do. So here I'll try to apply and show you the fast track how to do that, and we start doing the first one. All right, so what we have x squared minus 4x plus 2. I'll just use the formula because in this case I see clearly that I'll get x squared minus 4x, and if I add 4 and subtract 4, I'll get the complete square immediately, right? Remember the formula? A plus minus b squared, which is a squared plus minus 2ab and plus b squared. That's the formula. I use it here, and right now what I'm gonna do, I'll do that. It's gonna be x minus 2, which is squared, and here the rest part minus 2, and I already did it. You see, it's real fast right here. Okay, so what I'm gonna do, I just want to highlight my vertex, so coefficients or vertex coordinates. So I've got a vertex with coordinates 2 and -2. So make sure you remember that that's the vertex form. So k is -2 here, and h is just 2. All right, so I'm coming back. I erased the formula because right now what I'm going to do according to the question, according to the problem, I need to find equation for the axis of symmetry. Okay, vertex coordinates is done, then axis of symmetry. So axis of symmetry is the line that goes through the x vertex and vertically. Okay, so it's 2. So that's why I just simply put the line here. It goes through vertically through x equals 2, because 2 is the vertex. That's the starting point. But not the starting point. That's only x coordinates. However, we just need to have a look at the -2 as well. So my vertex is here, okay? That's the vertex. V with coordinates 2 and -2. All right, so next part. What I'm going to do, I just need to write an equation for line of symmetry. So we've got x equals 2 for the vertex. So this is the equation for the line of symmetry. The line of symmetry. Okay, we've done that. And so we also put it on the graph, put it on Cartesian plane, and now we need to sketch the graph. All right, so we've got vertex, and we simply can create the set of data in the table way, so we simply know the vertex. Remember, we use the vertex 2 as the middle point, and we just split around, so we know also y vertex, and we just put around data for x. So we just go with the step of 1. Here we just add 3, let's say, actually 4, yeah, but anyway, okay. So here we put one step back, it's 1 and 0. And now what we're gonna do, we just plug those values in the equation. So we've got, it doesn't matter actually where you're putting. You can put in your original equation here, or you can put in the vertex form. So it seems to me that simply use the vertex form because you have only to put 1x and subtract 2 and raise 1 time to the power of 2, so it's easier. So I recommend to put it here in the vertex form. Okay, so we've got x. Let's calculate. So 0 minus 2 squared is 4, and 4 minus 2, we've got 2, all right? So next we put 1. So here in brackets 1, and 1 minus 2 is minus 1. Okay, so obviously 2, negative 1, negative 2. So what do you expect to have for 3? Let's calculate. 3 minus 2 is 1, right? And 1 minus 2 is minus 1. So symmetrical, right? You remember y values are symmetrical around your median number when your x and y vertex coordinates. So that's why I just simply can't put 2. I can even check. So 4 minus 2 is 2, 2 squared is 4, 4 minus 2 is 2, all right? So that's why I recommend to use only one side, left-hand side, for example, for relating to the vertex, and calculate the values for y, and then symmetrically put it here. Okay, so let's drop the points here. When we have, let's do it for left-hand side. So when we have x1, negative 1 for y, so it's here, I'll use, let's say, green color here, and so that's 1 point. Symmetrically, I put another point, and when 0, we have 2. So when 0, we have 2. So obviously for 4, we'll get also level of 2 for y. So actually we smoothly connect with the line, with the, sorry, actually not the line, not straight line, but with the curve. And for 4, for x, oh, okay, yeah, we've calculated. We don't have like lots of data, and that's why we can smoothly just continue graphing. It should be something like this, okay? And also the left hand side symmetrically. So try to do it here, all right? So that's our sketch. That's our sketch. So by the way, just I didn't explain you, but so bear in mind that this is actually y-intercept, right? Y-intercept. I'll tell you later what it is, or you can watch in the video dedicated to x-y-intercept for the parabola. But here it's clearly seen that this is simply y-intercept. Y-intercept. If you need explanation why, you just simply need to put x0, because any point on y-axis, it has, so any point has x coordinates equals 0. So if you put 0 here and here, you just simply eliminate this part and you're left with y equals 2. So that's why y is the y-intercept exactly is equal to 2. All right, so we've done the first one. So make sure you have the same, and let's just accelerate for the second one. All right, so what we have for the second one, we have negative x squared plus 3x and minus 2. Okay, one more time, we need to define the vertex coordinates. Okay, so what I'm gonna do, I'll just have the vertex form with coordinates h and k, and what I'm gonna do, I just use the vertex form. Yes, actually, yes, we can do. Okay, I'll show you in two ways. So first, if I set up the vertex form, is negative x minus h squared and plus k, and then I just simply expand it. So I'll get y equals negative, then x squared minus 2hx and plus h squared, and finally plus k. So I'll have that one, negative x squared then positive 2hx minus h squared and plus k. So this, guys, is pretty long method, so if you want to do it, never try to do it if you're not stated using the, so you need to find the vertex form, because you can do much easier. So I just show you how to do through standard, vertex form, and right now I just expand it and use expansion approach to compare coefficients. All right, so what we know that this is the first term, we just compare with standard equation, which is negative x squared plus 3x and minus 2. And then I compare coefficient by coefficient. So 2h is coefficient before x, so it equals to 3. So from here, h is actually 3 over 2. 3 over 2, yeah, because 2h is equal to 3. Okay, and the rest part is negative h squared plus k should be equal to negative 2, right? Because this is the free coefficient. So I just put it, instead of h and k will be equal to negative 2. And when I transfer, I'll get plus h squared or plus 9 over 4. So that's k, and finally I'll get 9 over 4. And so instead of 2, I will use negative 8 over, let's say, nope, over 4, of course, and plus 9 over 4. Yes, because negative 8 over 4, this is an equivalent fraction for negative 2. Okay, so finally, what I've got here, let's simplify and finally figure out the answer for k. So k is negative 1 over 4, and hence we've got h equals 3 over 2, and k is negative 1 over 4. So I just move all that values here, and finally what I'll get negative x, so negative brackets x minus h is 3 over 2, so minus 3 over 2, which is squared, and plus k, so minus 1 over 4. So I just plug all those into vertex general form. All right, so we've got a vertex with coordinates 3 over 2 and negative 1 over 4. So we use the vertex form. However, as you can see, it's pretty complicated, like it's real long way. So for that example, I'll show you another way around. Okay, how to do it like really fast. Okay, so guys, hope you understand that. And what about axis of symmetry? So axis of symmetry is exactly a vertical line that goes through the vertex, x vertex coordinates. So I use again purple one, and 3 over 2 is here, right? So I just drop the line, vertical line that goes through 3 over 2. Okay, that point is 3 over 2. And what about negative 1 over 4? So we've got vertex somewhere here, right? That's our vertex. And then I put the graph here, and instead of like, I'm not going to create the table, but you know how to do that, right? So that's why I simply use some sort of like my experience. So negative 2 is a y-intercept. Yes, and your branches, actually, you have the leading coefficient a negative, so your branches, your parabola will go downwards. So it opens downwards, so that's why n2 is intercept, y-intercept. So actually at the same level we'll get for x equals 3. So we'll have this kind of curve. Yes, from the vertex point, and it goes down here and down here. Okay, so I hope it's pretty symmetrical. Maybe not so, but okay, that's my bad, because I'm drawing on the screen on my phone, so not really convenient to draw this stuff. Okay, but I hope you understand, right? I hope you understand. That's parabola, and you need to make your to make a benchmark what I have and what you have. So actually methods might be different. However, I just demonstrate how it works, how to get the general form using expansion methods. All right, And here, as I promised to you, I'll use the fast track, how to do it very, very fast. Okay, so just remember that x vertex is negative b over 2a, so we can do it in a second. Negative 2 over 3 times 2. So that's why x vertex is simply 1 over 3. Yeah, two negatives actually cancel, and 2 also cancel. So we've got 1 over 3, which is positive. And how to calculate the y vertex? We simply need to put that 1 over 3 instead of x's. All right, so we've got 3. So one more time, I clearly show you that we plug 1 over 3 into the function, and that's how we can find y vertex coordinates. Okay, so that's h coefficient, as you remember, and y vertex, this is the k coefficient, so we use that. And from here we can calculate 1 over 3. So 3 times 1 over 3 squared minus 2 over 3 and minus 5. Okay, so that's for k or y vertex. We'll get 3 over 9, which is 1 over 3 finally. Then negative 2 over 3. And instead of 5, I'll get 15 over 3. Okay, we've got all that as fractions. And now we just simply do operations with numerators. So 1 minus 2 minus 15. Okay, so finally we'll get k value as negative, so 1, 2, yeah, we got negative 17, so negative 16 over 3, that's k. So finally we've got the vertex with coordinates 1 over 3, that's h or x vertex coordinate, and negative 16 over 3, that's the second one. All right, so x vertex, the line of symmetry, should have an equation 1 over 3 equals x, and it's vertical one. So again, I put the vertical line here, 1 over 3, somewhere very close to 0. So I'll just put that as the vertical line. It's very, very close. Oh, my bad. So actually, I need extra zooming in. And now I can put more or less vertical line here. It goes through the point 1 over 3, and because 16 over 3 is about like 5 something, so negative 5 something, so it's going to be here, right? That's the vertex coordinate. All right, so in your parabola should go upward, and this is going to be y-intercept, so we've got something like this. That's our parabola. So actually, normally, in order to sketch, you need also calculate x-intercept, right? In order to calculate x-intercept, you need to solve quadratic equation. To calculate x-intercept, you need to solve 3x squared minus 2x minus 5 equals 0 in order to get precise x-intercept. But if you are not asked, just create the table for x, y, and from there try to build up like some points, and this will be your kind of approximation how it will go through x-axis. Okay, but normally you need to solve in order to get x-intercept, Okay, so we've got this one also. Oops. And we just go down for the last one. Okay, so y equals 2x plus 1. So here, this is the vertex form, right? Oh, almost the vertex form. However, what's the difference? So normally we need to have x minus h squared in plus k. So what's the problem here? We have 2x instead. How to come to this form? So you just simply need to factorize 2. So we'll get this one first. So we factorize 2, and we got x plus 1 over 2, right? And we square it up. So x plus 1 over 2. If expand the brackets, you'll check yourself that you'll come back to 2x plus 1. All right, then 2 power distributed to 2 and 2x plus 1 over 2. So 2 squared will give you 4, and that's how we get this form. So actually this is a, right? So normally if a is not equal to 1, so we need to write clearly that this is like some coefficient. In this case, a is simply 4. Okay, what's left in the brackets, we'll get x plus 1 over 2, which is squared. And now we've got the vertex form from where h is simply negative 1 over 2 and k is simply 0 because the free coefficient is absent. Okay, our parabola goes upwards, so make sure you understand that, and vertex form is simply negative 1 over 2 and 0. So axis of symmetry, x equals negative 1 over 2. This is axis of symmetry. And what we just need to put this line x equals negative 1 over 2 right here. So Cartesian plane, okay, goes somewhere here. So through the point x equals negative 1 over 2, this is the axis of symmetry, yes, for our parabola. And now what we're gonna do, we just need simply to put the vertex. So the vertex is exactly here. That's also the vertex with coordinates negative 1 over 2 and 0. Just let's compare it with what we have. Okay, and this is starting point, so you branches up if you start, let's say, if you start expanding this expression, finally you'll get plus 1. That's going to be y-intercept. So y-intercept is through the 1. So that's why your parabola would look like the following. So it goes like something like this. Coefficient 4, leading coefficient tells you that it's actually scaled up. So it's like really narrow because of coefficient 4. And this is your parabola, okay? I'm not going to plot the set of like data in order to do it precisely, but you guys need to do that. So for those who are not sure, just go back to the very top. Here I did it for the very first example. I consider it in really details so that you can check your workings, okay, and compare it and make benchmarking with mine. All right, so we've discussed quadratic function for how to find vertex, how to find axis of symmetry of parabola, and how to sketch the graph. So in the next video, I'll show you what x and y-intercept means, how to find them, and this will be the recap for the whole quadratic functions theoretical basis. And also I'll create a revision set for like to solve different problems with like several questions for each problem. That's normally for GCSE stuff, and hope you like that. Don't forget to subscribe. Don't forget to share your ideas about how to improve the way I trying to give knowledge to students and help them in their hard life at school. So just keep joining, keep like enjoying, and peace.